Day 18. 12 more days to go. So this is, I believe, all in scales. I don't know if you need a calculator. Maybe. So question 1. A book on aviation has 2 pictures of the same airplane. These pictures are similar in shape and size. So same airplane, but one is obviously smaller than the other. Which scale? What is the scale from the larger picture to the smaller picture? Well, you can. What's the relationship here? How does a 6 becomes 1.5, where 6 times what times 1 is 1.5? I need a calculator. So the scale here, and you can go either way. What's the scale from the larger picture from big to small? Okay, so from big to small, obviously, it's going to be reduced. So so we can set up equation 6 times something equals 1.5, and then we can divide this by 6 and this by 6. So x is going to be 1.5 divided by 6, and that's going to give us 0.25. So this is a scale that we want to use, right? So we're going from big to small, and we can set it up in this way, right? And if we go from small to big, so we're looking at going this way now, going the other way. 1.5, how do you get to 6? So 1.5 times the number x that I don't know equals 6. We divide by 1.5 on each side, then I get that x equals 4. So so the scale here is times 4, and then you can realize that this one, if you multiply 1.25 times 4, you get 5. So one is being reduced, right, by 1/4, and the other one is, so to go that way it's 4, and to go this way you divide 6 by, times 6 by 1/4, or times 0.25, and you get 1.5. So it really depends on which way you're going. So on the map, the distance between 2 towns is 4, so let's call town A town B, and the map is 4 3/4 inches. I'm just labeling. The actual distance between the 2 towns is 380 miles. So what is the scale on the map? So we can set it up. So I can write, I'm going to write 4.75 inches is equal to how much? 380 miles. So that's what we know, right? So that's the relationship we know. But we want to find out what 1 inch is, right? So every inch. So how do I get that? I can divide by 4.75 and divide the bottom by 4.75. So 4.75 divided by 4.75 is obviously 1 inch. So, and then the bottom 380 divided by 4.75, you get 80. So every inch on that map equals 80 miles. Answer is C. Number 4, Jason made a model sign for his model train set. Model stop sign. The actual sign measures 12 inches on each side, so I don't know. Does that look like a stop sign? So each side here measured 12 inches. Okay, and here's his model top sign. The actual one, okay, the real one's 12 inches, and the one that he made, which is very tiny, measures 0.5. What is the scale of the model sign to the actual sign? So we're going from small to big. So 0.5 to 12 inches. What do you have to multiply 0.5 times to get to 12 inches? So again, you can ask yourself, 0.5 times this number that I don't know equals 12 inches, right? So you can set it up this way, and we can just divide. So basically, we can divide 12 and 0.5, so that's exactly what we're going to be doing. 0.5, and you're going to get
Hanson Ewing, please come to the main office. Hanson Ewing, come to the main office.
124. Okay, so the multiplier here is 24. Okay. Just give me a second here. Let me pause this. I'm going to stop for a second. Pause. Boom. Okay, so back. So now, I don't even know where I am anymore. Number 2, a carpenter sketched the scale pattern for the top for a new entertainment center. The entertainment center is said to be 72 inches wide. By what factor must he multiply all his measurements? So this is obviously the drawing, but in real life, this is going to be 72 inches. So, and I want to know what the height's going to be here. So what am I going to multiply? Obviously, the 6 to get 72 was times 12. So here, to get this height here on the real one, it's going to be times 12. So we're not asking for the actual measurement, we're just asking what the factor you're going to be using here. So obviously B, right? And I got that from the relationship between 6 and 12. On the map of Alaska, 1 centimeter is 80 miles. So I'm just going to write that like this. And the distance between Anchorage and Oscarville is 480 miles. So what is the distance? So in real life, distance between those two towns is 480 miles. So on the map, how many centimeters would that be? Well, here is very easy setting up proportion to find the relationship here is times 6. So here is also times 6. So on a map, that would be 6 centimeters. Okay. Number 7, Jack is using using the plans shown below to build a deck. So here is the deck on his drawing, right? He wants something that's going to be this length and this wide. And here's your key. Based on Jack's plan, what will be the actual length of the deck? So looking for this. So let's write our relationship. So 1/4 of an inch is going to be 1.5 feet in real life. And we want this, so but in the drawing we have that it's 3.25 inches. So what is that in real life? How many feet is that? So I'm gonna change this 1/4 to 0.25. So you need to find the relationship here, right? 0.25 times what number is 325? You can just divide 3.25 divided by 0.25 and you're gonna get 13. So the multiplier here is 13. You're gonna do that here too. Times 13, and 1.5 is going to give me 19 points. So in real life, this is going to be 19.5 feet. Okay, oh, there it is. The actual distance from Cleveland to Columbus is 142 miles. About how far apart are Cleveland and Columbus on Dan's map? Where's Dan's map? Okay, here, so let me write the relation. So I know that 2 centimeters on this map equals 25 miles. So they measured the actual distance, and the actual distance from Cleveland to Ohio is 142 miles. So what is that in centimeters? So I'm missing this part over here. So find the relationship here, right? 25 times something is 142. So let's divide 142 times 142 divided by 25, and that's going to give us 5.68 exact. I'll multiply the top by 5.68 times 2, and so on the map it's 11.36, and obviously they rounded this to the nearest hundredth, and we get 11.40. On a road map, the distance from Salem to Lancaster is 2 1/4 inches. So the map scale shows, so 1/2 inch on my map is 30 miles. So somebody went and measured with a ruler, and they said that 2.25 inches is the distance from Salem to Lancaster on the map. But in real life, let's find out what that distance is in actual miles. So find a relationship. 0.5 times what's 2.25? You can just divide 2.25 divided by 0.5 and you get 4.5. So here's our multiplier. Times 4.5 and the bottom times 4.5. We're going to get 135 miles. Middle 7th. A photo is 4 inches wide, and so John has a photo, so here's her picture. And we're going to write that this is 4 inches, and this is 6 inches. She's enlarging the photo by a scale of 1 to 2.5. What is the new measure of the length, though? So she's making this bigger. So every inch is going to be 2.5 on the new one, so this is our times 2.5. So if we multiply 6 times 2.5, it's going to be 15 inches. Right, so I'm going to use this. Right, 1 inch equals 1 to 2.5, so every 1 here is 2.5, so 6 times 2.5 gives us 15. 10. The Wright brothers airplane flyer had a wingspan of 484 inches. Carlos bought a model of the airplane. The model should use a scale factor of 140. So the real airplane, the wings, okay, this one is 484 inches. A lot of inches, right? So, and Carlos bought a smaller one, right? I mean, this is obviously not scale, and they use a 1 to 40, so it got reduced. So all we have to do is take 44 and times 1 over 40. We just divide by 40, whichever one you choose. That's going to give us 12 points. So in the model that he bought, it's going to give us 12.1 inches. 11. A scale model of a sports car is 1/24 the size of the actual car, and the actual car is the diameter of each tire. So this is the real car, the real tire, and the diameter is 48 centimeters. So, but the real, the model that, and again, obviously I can't draw a 48 centimeter tire, so just pretend this is the real one. So this one, the model that you bought at the gas station for your little cousin or nephew or little brother, it's 1/24 of that, right? So we're going to take 48 and reduce and multiply by 1/24, and you're going to get that on the model. It's going to be 2. So this actually on the toy car, the diameter is 2 centimeters. So now can you find the circumference of the toy car? On the toy car, the wheel has a diameter of 2 centimeters, so 2 times pi d. Circumference is pi times 2, and circumference equals 2 pi, or if you want to, so you either leave it at 2 pi, what is it, centimeters, or multiply 2 times pi, and you're gonna leave it in near 100, simple. What is it that we're doing? Rounding into nearest hundreds to 6.28 centimeters would be the circumference of this little tire over here. 13. Janice had a 5-inch high, so this is 5 inches. This is 3 inches wide photo. Right? So she enlarged to a 3.5 foot tall, so she made a huge one, right? And she made this 3.5 foot tall. So 3.5 foot. What should be this distance over here? So now the problem is here, if you go, okay, 5, just 30, it's times whatever, 0.7, right? Yeah, a second. 3.5 divided by 5 is 0.7, so 5 times 0. That's not the scale factor. How much did it grow? It grew by a lot. So the problem here is you have to change this 3.5 foot to inches, right? So 1 foot is 12 inches, right? So 3 feet is 36 inches. But you want 3.5, so we're going to add 6, not the total. So this is actually 42 inches, right? So now you can find the scale factor. 5 times what is 42? And 42 divided by 5 equals 8.4. So it grew 8 times 8.4. So the size got enlarged by a scale factor of 8.4. So which means this is going to be times 8.4. 8.4 times 3. 25.2 inches, but you understand that all my questions here are in feet, so I have to go back here. So I know that uh, 1 foot is 12 inches. So in here, how many there we go. How many groups of 12 can I have? I can have 2 groups of 12, so it's definitely 2 feet. And I'm going to have 24 inches, and then I'm going to have 0.12 left, so that's your final answer. So the trick here, if you guys found that scale factor and you left this in feet, 5 times what's 3.5, you would have definitely gotten this wrong. Okay, so it's actually a decent question. 13, 14. Where are we? 14. Scale drawing of a rectangular room. So we have a rectangular room. It's 6 inches by 8 inches long. So this, I guess this is 6 and this is 8 inches. Right, so the actual room, and I'll make the actual, well, sort of, is 12 feet wide. We're missing for this one. Right, so quickly, right, times 2. Uh-oh, no. And again, I'm making the same mistake. So this is 12 feet. And 12 feet, hang on a second. Well, they have to be in the same rooms. 12 feet is 72 something, 72 inches. So that's times 12, and that's times 12. There's something wrong with this question. Just give me a second. 14. Pause. No, I was wrong. You have to change this. I'm not asking for the scale factor. So if 6 inches here, so every inch is what do you call 2 feet, right? So this is times 2. This would be 8 times 2, which gives us 16 feet. Which makes me want to go back to the other question. So right now that's okay. 12. Which one is it? What's the question here? This one. Hang on a second. So 5. So 3.5 divided by 5 is 0.7. So 3 times 0.7 equals 2.1 feet. Yeah, actually, I get the same answer. All right, so nothing. Forget it. So actually, no. All right, let me go back to this. You had a 5-inch times 3. So this was 3. This was 5-inch. So and this was 3.5. And this was the answer. So multiply here is 0.7, and I could have just multiplied that by 0.7, and I would have gotten 2.1. And if you did it the way I did it before, changing everything to inches and then back to feet, you would have gotten the same answer. Well, we did get the same answer. I don't know why I'm making it longer. Sorry. 12. She wants to build a copy of the stained glass window. So here's the original window. She wants the shapes in her reduced copy to be similar to the shapes of the original. Select dimensions of each. So if that's 30 in the original, in the reduced copy, she's making it 15. So obviously she reduced it by half, right? So or divided, so she multiplied by half. She reduced it by half, and that's what we should be showing. So this one also, she's going to multiply by half, and 12 times the half is just that part of the reduced copy is going to be 6. 15, on a blueprint for a house, the front of the house is shown as 12 feet wide, 12 feet inches wide, 12 inches from the house, and the height is 14 inches. Okay, so if the actual house, and again, definitely not the proportion, this is the actual house is 30 feet wide. How tall is this house? So we're looking for this measurement here. So let's find a relationship here. 12 times something is 30, right? So we can divide 30 by 12, and that's 2.5, right? So I can multiply 14 times 2.5 as well, and that's going to give us 35. So in real life, the height of that front of the house would be 35 feet. Here's our answer. Okay, So that's it for day whatever this was, 18, I think. Nope. Pause.